Hey, everyone. Thanks so much for tuning in digitally, I suppose. This is new for me. I'm sure it's sort of new for you, but this is the space we live in now, and I'm excited to be able to give you a talk one way or another. So my name is Andrew Johnson. I'm a lead developer at Fluree. Fluree is a platform, a data management platform where we've built out graph-based data solutions on top of ledger-backed blockchain data, and really sort of are powering data for a sort of Web3 environment. That's very jargony and a little bit convoluted, but hopefully some of the things we talk a lot about at Fluree are some of the things that I think I'd like to talk about today, and I think would be interesting to anyone who is working with front-end technology in an increasingly data-centric world, which I think is pretty much all of us. So today specifically, I'm going to be diving into what it looks like to build front ends, reactive front ends in particular. So if you're familiar with React JavaScript, you're going to be familiar with what we're talking about today. But in a world and in an internet that is moving towards data centricity. So to quickly dive into a little bit of what we mean with data centricity, or at least what we're thinking about it with Fluree with data centricity, there's really two sort of ways to begin to think about this. And one of them is a little more boring, but I'll start with that one. That's the way that you're probably thinking of it as soon as I say it. So we're talking about back-end architectures. We're talking about database management and building out APIs and all of that. A great example of the need to move towards data centricity, and large enterprise platforms that are managing their data all are sort of aware of this, is the idea that as we continue to build out platform after platform, we're finding that what we do is we build out increasing numbers of data lakes and data silos that cause issues, optimization issues, security issues, et cetera. It's expensive mostly from just a level of development time and maintenance, but it can be costly too if we're talking about a huge data breach. If you've heard of any of the big, personally identifiable information breaches related to social security, banking, those usually aren't happening at the database layer. They're happening at some of these data lakes where we're essentially pulling data away from the location where it's originally housed, around which we're building security based on what that data needs to do. And these data lakes, although they're necessary to sort of power a bunch of different platforms in an application-centered world, are just a big problem. And most enterprise technology realizes that. So data centricity in that regard is thinking about how do we give data the possibility of governing itself? How do we allow for data to be flexible and open so multiple platforms can integrate with it, while still making sure that at the level of the data is defending itself, it is transparent, it is traceable, it has its own history, all of that sort of thing. So we care about that a lot at Fluree. We care about that a lot in the sort of enterprise data world. And I think the issue is, unfortunately, we often don't realize how much this is a front-end conundrum as well. So maybe a more exciting example of what it looks like to think of front-end technology in a data-centric world is thinking about what Facebook has done in the past 10 years. And I'm speaking specifically of GraphQL. So this is a slide a Facebook engineer provided at a talk at QCon in 2011 before they had introduced GraphQL. And what we're seeing is sort of the legacy way before GraphQL of thinking of how data is getting to sources. When you have a complicated front-end app or a front-end app that needs to do some really neat things, you're talking about building out REST APIs to take data from a variety of different sources and pipe it into the application. And a lot of the time, there's nothing wrong with that. For years, Facebook had a really neat platform that did really neat things on their desktop app, and they were totally fine with the REST APIs. What happened is at the point where they wanted to start developing their mobile app, they realized that none of those REST APIs were going to be sufficient for the sorts of things they needed on that mobile app in particular. And the discovery was that they had built essentially an application-centric infrastructure. They had essentially set up all of their data and the way their data was getting exposed and the way their data was getting secured based on what this application needed. And once they had another platform, another application that needed new data, they no longer had, the data wasn't flexible enough to be able to pivot in that way. So GraphQL, for those of you who are familiar with it, largely was a way to move this front-end architecture to a data-centric model. So specifically what we're talking about with data centricity in GraphQL is that instead of REST APIs, and this is just sort of context here before I dive in, instead of REST APIs, we're talking about a declarative, semantic, transparent schema that maps out the sort of comprehensive structure of all the data we're talking about. And instead of, if you have a feature on Facebook that's showing all your events, and you have a REST API that's providing that data for that feature. If you suddenly needed to know all the names of the people attending those events, instead of having to update a REST API for that specific feature, potentially a specific feature across several platforms, we have this declarative sort of schema that's able to show us exactly how you would crawl the graph association from the events to those people. And just from your front-end app, you just update the data retrieval code. You don't have to do anything on the back end at all. And suddenly you have that much more, you have richer data than you had a second before. More importantly, you can power multiple apps based on this data. The data allows for this sort of machine-to-machine interaction. Instead of a single pipeline, you're pushing data down one way or another. So this is, I think, a cooler, if you've worked with GraphQL, and especially when we talk about frameworks like Relay, if you've worked with GraphQL, you've seen probably some really neat things it can do. You suddenly want to scale a feature on a front-end app. You don't have to talk to your backend team at all. Your backend team doesn't have to develop an API for you. You are literally just looking at the schema, following some schema pattern, changing the code that is in your front-end app that's handling your data retrieval, and suddenly you have just this totally new feature, and the amount of work that went into it, the amount of effort to scale that was just significantly lower. There's been some cool realizations since that. If anyone's worked with React Relay, the idea there is that we've realized that what's happening in state management for an application, when you are trying to figure out how to organize all the data available to an app, that's essentially a very similar process if you're familiar with Redux or context or anything like that. That's a very similar process to when we are determining how to handle graph schemas and retrieving from a graph schema. So what a framework like Relay allows us to do is not only set up our data retrieval from an external graph server using Relay by wrapping some components in a specific query, but we actually are able to set up our state management at the same time. So we're sort of pre-fetching data in, and then when we need a component to actually access that data, it's happening in memory because it already exists in the application layer. So all of that's very cool. It's a very neat example of how front-end technology has gotten way cooler, more robust, more feature-rich because of a move towards data centricity. But one question we've been asking is, what's the next step? What are the issues that we face currently if we're using GraphQL or sort of graph front-end technology? How could we actually move towards a more data-centric model? And what would that improve? So I think an obvious place of improvement would be authorization, right? We're still having to handle authorization at the graph level. The data has no knowledge of how to defend itself. If someone was to get past the graph level or in the authorization that's happening there, there's still very exposed, vulnerable data. We also don't have sort of full, as a result of that, I guess we don't have full transparency or openness to the data. We're still at only getting, the data centricity stops at the level of the sort of graph server. So we still are not getting a sort of fully public machine-to-machine sort of infrastructure there. And I guess if you're hearing this and you're familiar with maybe a certain tech space, you might start thinking of you might already have an idea in mind of what the next step would be in moving towards data centricity. And maybe that is blockchain or Bitcoin specifically, or Ethereum or some of the other really well-known public-facing blockchains. And I think that there's something to that. I think, these pieces of technology, they are operating where not hidden behind any sort of firewall or API, right? The security of the data is happening at the data level itself. Those rules are embedded in the structure of the data. It's able to be fully transparent and open, but while also being protecting itself based on these rules that are essential to the way that the data needs to be exposed safely. So there's something to that. And you certainly can build some really neat apps on something like Ethereum, dApps or dApps. So with that said, though, I think anyone who has tried to build apps on that technology maybe knows that that level of data centricity, if we want to call this the sort of ultimate data-centered approach, isn't necessarily the data we need to power an application. If you have ever built an application on Ethereum, you know that you're just taking, if you're writing data to Ethereum, you're writing very small snippets of data, essentially small text logs or something like that. If you were to try to put a gig of data in Ethereum to power an app, and by database standards, a gig of data these days is nothing. it would cost you literally upwards of $10 million, right? So these cryptocurrency blockchains were built to be a backbone for cryptocurrency. They were not built to power data in any meaningful way. They were not built to run as a data management platform in any meaningful way. So, we at Fluree, we and sort of the front-end community who are obsessed with GraphQL, we are interested in these moves towards data centricity, towards openness and semantic declarations of the shape of data, towards a more data-centered approach to security, et cetera. But I don't think right now that Bitcoin and Ethereum are the answer, if that's the question. So we've been having at Fluree this conversation a lot, and I'm going to talk about a sort of solution we have thought through at Fluree, although I don't want to pretend that Fluree would be the only way to care about data centricity and to build apps on a data-centered platform, but in some ways it's the only way that can do all the cool things we've discussed with blockchain and all the cool things that we've discussed with front-end technologies powered on graph data. It's the only one we know of that's doing that all at once. And hopefully today I'm going to talk a little bit about how we see that working, but even more importantly, I'm going to dive into some code. We are going to build in about 10 minutes a front-end app that is powered by graph data, that has the traceability and security of a blockchain ledger. And we're going to do some really cool things that you couldn't do with Bitcoin and you couldn't even do with GraphQL. So we'll talk about that now for a second. What's going to power that? So on one level, we're talking about a blockchain ledger. At its essence, all Fluree data is being transacted into a blockchain ledger where every new block is part of a cryptographic sequence that ensures the integrity of every moment of data in that. If you are writing rules or permissions to the data platform, you are writing them to this ledger. So if you are saying, like in Bitcoin, you can only query your own wallet balance, or also in Bitcoin, if you're going to withdraw or if you're going to add to your wallet balance of Bitcoin, you have to remove an equivalent sort of Bitcoin token from another balance. Those sorts of rules, we think are very valuable. We're talking about data having the possibility of defending itself. And so all of that exists in Fluree in the way that we are thinking about the ledger. All of those are embedded in the ledger, and any sort of query or transaction has to first approve itself based on any sort of embedded rules that you're talking about. But we are also talking about not just querying ledger data. We are thinking of a way that at any given point, we also have a graph database that's sort of being spun up out of the data at a moment in time of the ledger. That's maybe an important point to talk about. When we're talking about a ledger, we're talking about data moving through time. Every time we add a block, we are talking about a new moment in time and the state of data at that time. When we're talking about a database, we're really not talking about a time at all. If I have a record of user where a username is Andrew and I update the new username to Lillian, the database is now user with a username Lillian. And you could have logs or security, or you could add some time-related data to try to track that. But essentially a database, in its core doesn't care about time at all. It's a snapshot of data. If you are building a database out of a ledger, what you immediately have is data built out of a moment in time. And so if we're talking about a general database built on a Fluree ledger, we're talking about the most recent shape of data. But you also have full record of the sort of historical ledger of that. This is the same with Bitcoin. This is the same with Ethereum. You can not just ask for the state of data now. You could ask for the state of data yesterday at block 2. You could ask for the state of data 5 minutes ago. And what we think about at Fluree is that at any moment that you ask a question of data at time, you're asking essentially for the database as it spins out of the ledger at that moment of time. So that's one cool thing that GraphQL or graph-based data, can't do at this point, because, at that point we're talking about a database that is limited to a snapshot of data. We're not talking about something that travels a historical ledger. We're also talking about the ability to have permissions for graph data written at the ledger level or at the data level. So you can imagine having various different participants in a platform spinning up their sort of query servers for ledger data. You wouldn't want them to be responsible for writing the authorization permission for each of those different servers. So right now, if you're running an Apollo server, right, your resolvers that you're running on the Apollo server determine a lot of the authorization. Just like on a REST API, you would have some sort of authorization logic to make sure that the person trying to get the data should be getting the data. We agree with the sort of blockchain world that that data should in some ways be able to protect itself, because if you can get behind that layer, there's really nothing stopping you from being able to tamper with or update that data. And the second thing that we're thinking about with Fluree when we're talking about the value of a sort of graph data layer and the value of a ledger layer that are separated, we also get the opportunity to separate sort of read processing and write processing, or query processing and transaction processing. And this is valuable too, because a lot of times you don't necessarily want to spin up a ton of different transactors on your ledger level, but you might want to build a huge, immense content delivery network on the read level to speed up read times for your apps, or as we might see later, actually to embed a query peer server into the fabric of a web app itself. Maybe it loads as a service worker in the background. That's a little spoiler. We're going to see that in a second. So this is the sort of shape of data that we're talking about at this point. And in terms of what that looks in terms of a network infrastructure, at the most basic level, we're talking about something that looks really similar to a sort of Apollo server running GraphQL. So in the diagram here, we're specifically looking at an application layer that is bypassing an API. There's no need to build out a new API for every single piece of data retrieval. It is just getting in touch with a query server, which of course is going to have something like a graph schema, where the graph schema is essentially declaring all the available data and all the different ways you can query that data, and the application or the code being written at the application level gets to decide what it's doing. This is essentially the most basic way you would run Fluree. The addition, however, of the ledger means that query peer server, or in GraphQL, that sort of Apollo server layer, every single time a new block gets written to the ledger, that ledger is pushing out the newest block state, the newest index segments of that block state to the query peer server. So the query peer server is going to always have the most immediate database state available to it. And so right now, when we're looking at this diagram, we have essentially nothing different than what is happening with GraphQL and Apollo. What becomes really cool is that in this situation, you actually can embed, because we can spin up new query peer servers very easily. And in fact, we're going to do it in a demo in a second, and it's going to happen effortlessly. You won't even see it happening. Because of how easy it is to spin these up and connect them to the ledger that needs to be pushing new data to them, you could actually embed it at the level of your app. You don't have to worry about the security of letting the application load up the query peer server, because the security is being handled at the ledger level. All of the permissions, all of the authorizations, all of the restrictions of who can access what data is built into the data itself. So the application itself, gets to be sort of agnostic about that. There's no security risk in running this query peer server inside of the context of your app. And what you get, if we think back, let me just hop back for a second. If we think of this relay pattern, right, where we are not only connecting a component to a query, and relay is sort of prefetching that data from a server, we're actually talking about having all that data running in memory in the application you're running. So we have instant speeds. We're not talking about any network request at all. Every single time the ledger gets updated, the query peer server will get updated, which also means because of React's repainting and clever diffing and re-rendering, we're getting, at the very moment that a new block gets pushed to the ledger, your app, if it has new data that would respond with new data to a query, is also updating immediately in time. So we think this is really cool, and we think this is maybe the sort of future we can move to as we think about how to build out really cool front-end features by moving towards a data-centric approach. We're going to get the sorts of features I'll show off in a second, but these really neat data over time features, really neat in-memory query speeds. These sorts of features are what are opened up when you are able to allow data to defend itself, when you're allowing that data level to be the sort of center, and it is talking or communicating with a bunch of different machines who need info from it. So without further ado, I'm going to jump very quickly over to let me minimize this, my terminal, and I'll try to make this a little more readable for anyone looking at my screen. Okay, if you've built with React before, you've probably used Create React App. And that's essentially what I'm just going to do right here. I'm going to start up a brand new React app, and I will call it TDT Demo for the Triad Digital Tech Conference. And I will use a Fluree template. Anyone who wants to do this at home, this is a public template. It allows you to leverage a lot of really cool Fluree features if you're connecting it to a Fluree database. And so all that's going to happen is we're going to start up this app. It's going to pull down this template from Fluree, and we're going to have a React app that's primed to know a few things about how we're going to interact with a Fluree query peer server. I'll talk a little bit about that once it's finished. In my other tab, though, I am going to just run a local instance of Fluree. This is a free community edition. If you go to our website and download the community edition, this is exactly what you're going to have. This is just a blank database. I'm starting totally from scratch. So I encourage you to do that if you want to code along during this or after this. So all I'm going to do is start up my database. As it starts up, because I have not set up a ledger yet on this database, it's going to sort of bootstrap some the sort of immutable structure that's going to really power any ledgers we start writing up. And importantly, it's also going to spin up a native query peer at localhost port 8080. And I'm going to be able to dive in here and immediately get a sort of admin UI for the database. This is where I'm going to just make a new blank ledger. I'm going to skip over just a few of these features. I'm not going to speak at length about what's going on here, but I do encourage you, if you're interested in a little more of the Fluree technology that doesn't relate to this specific demo, I encourage you to go to our site. We have documentations and guides and videos of all of this. But as I jump in here, we're going to call this TDT demo test. And we now have what we have essentially done is we have written block 1 of our new ledger. And if we actually go back to our logs, we see here that the moment we made that first TDT demo ledger, we have made the sort of system collection. We've bootstrapped all the sort of system collections for our blockchain. We now have one block that is the sort of starting block, and anything else we do, we'll begin to add blocks 2, 3, 4, etc. Again, I won't go into the blockchain technology here that's powering this, but I do encourage you, if you're interested in it, to look at some of our other videos or guides. Now that the database is up and running, I want to switch back really quickly to our Create React app. It should be finished now. And if I just move into that repository, actually, I'll move back. I'll open this up in my code editor. And what we have over here is a basic React app. If I go ahead and, just like if you started to create React app normally, we are essentially just setting up some basic configuration. We can go ahead and start this and run it locally. It's going to run in our web browser on 3000. And I'm just very quickly going to connect this to the database I just built, which was TDT demo/test. Okay, if I now come in and start this, so locally sort of serve up this web app, we are going to get in a localhost 3000 this React app that is where the UI is basically just being generated by the template. And specifically what's going on here, which is what I want to get into, is when we told this, and let me make this a bit bigger, when we told this to connect to localhost 8080 on TDT demo, we're essentially wrapping all of our code in a provider that's connected to that. In the back end of the browser, we're starting up a web worker that is launching as the web worker launches, it's actually doing what I had just alluded to earlier. It is starting up a brand new query peer. So instead of having like a GraphQL Apollo server that's external that we're fetching our data from, we actually have that server running in our browser. And obviously that could be a memory issue. You can run it very flat. You can run it very robust. For this, I'm going to run it very flat. So you could have it take no more than sort of like a meg or so of memory up, just to run a small query peer version that's specific to the sort of data that you want to get from it. But what I've done is I've connected it to that, and by default we're running just this sort of collection table, where in the same exact pattern as Redux or something like that, or Relay, we are taking a query. In this case, we're asking for all the collections. Think of tables in a SQL database. We're asking for all of the collections, and we are then just passing in a vanilla React component. And what we get back is this vanilla React component table where the data being piped in is the result of our query. That query wasn't issued externally. The query went straight to the database that's running in memory and was able to get that just absolutely immediately. If I, and when I in fact, go to our ledger and transact a new block, if that block would mean new data for that query, we're going to immediately see in our app that data represented in the UI, because the query that's connected to the React component is going to immediately return new results. Again, it's not too much different than what Relay or a GraphQL sort of React pattern is doing, but again, I think it's just so cool that we're not actually leaving, none of that data retrieval is leaving the app. It's all happening in memory speeds at the application layer. So what I want to do here is in the database, I want to go in and just transact a really, really basic schema. So I'm going to hop over. I have this just so I can copy and paste it. The schema we're going to be working with is going to have events, and really that's it. The events will have a title. The events will have attendees. And for the attendees, we're going to use what's a system collection. So one of the collections that just natively booted up when we started the ledger. We're going to use the user collection to have a bunch of attendees. So an event could have 4 attendees. All of those attendees will be references to the user collection where they'll have a name on the username predicate or on the username data field, so to speak. So if I go ahead, oops, I'm going to transact this. If I go ahead and transact this, what we're going to see, 2 things. One, we're going to see, first of all, we're on block 2. If you care about the blockchain metadata here that's guaranteeing the sort of validity and integrity of the data based on the sort of cryptographic hash of the previous block. All of that is sort of being returned down here. I don't want to dive too deep into this because I really want to focus on some of the front end pieces here. But if you're interested in that sort of stuff, if you're interested in what's happening on the ledger level, I encourage you to look at some of our other material. And if we hop back over to the web app, one thing I want to point out is without actually refreshing that web app or without having any code that just is triggering data requests over and over and over, we immediately got these new collections and the new predicates on those collections showing up in the table below. Why is that? And so just to allude to this again, the ledger got a new block. That block immediately pushed new block segments and index segments out to all the query peers. We're running a query peer in this app, and we have this component connected by a specific query to that query peer. The specific query is asking for all collection data. Since we just transacted new collection data, our front-end app immediately knows about that, and because of the ability to sort of check diffed content in React, that's getting immediately painted to the screen instantly. As I get into some of this a little in a second, I will show these side by side so you can see how this is happening just immediately right out the gate. So the next thing I want to do is actually transact just some seed data in. So I've put this schema in. The database can handle events. The database can handle users. So I'm going to add in 4 users. Each of them just has a username. It's very, very basic. And then I'm going to make 2 events. One event is going to be called how to code good. And the other event is going to be called how to code pretty bad. And luckily, more people are going to the event called how to code good, which is not an English event about grammar, by the way. It's a coding event. So I'm going to hop over here, paste in this seed data transaction, adding those 4 users and the 2 events. And now our database has some info in this. So if I hop over, Fluree, by default, our sort of proprietary query language is just JSON data. So those transactions I put in, you'll see they were just an array of JSON objects. We do, however, support GraphQL. And what would GraphQL look like in that case? So we just added events. Let's say I just want all the events and add all those titles and the titles for each event. A GraphQL query would look like this, right? And we've talked about already the value of GraphQL. Let's say there was a UI feature that was asking for that data. If we suddenly needed to scale that UI feature, we actually wanted to know not just the title of the event, but we want to know all of the attendees that are coming specifically by their username. We don't have to change a REST API. We don't have to update that. We don't have to do anything on the back end at all. We can follow the schema by which we know that these events have attendees, that the attendees have usernames, and we can immediately get back a response to build out our UI features that includes all of that data. So on this side now, I'm just going to change out the default template code with a little bit of code that will let us show, it's going to show, I'm just going to generate a single card for each of these events. So if I, hop over to my app, I'm going to just pull in some material UI code so I don't have to worry too much about styling. We'll throw that in there. Here's my very basic CSS that's going to style some of these components. We'll throw that in here. And then, as I said, we want just a single card for each of these events. The event component is going to map out all of the events to each one of these cards. And there's one other piece, which is the Fluree connection I'm going to put in here as well. The Fluree connection is, of course, going to resemble almost exactly a relay connection or a Redux Connect connection. What we're essentially doing is we're taking a query, select the title, and then the attendees, specifically the username of the attendees from events. We're going to connect that query to the component of events, and the results are going to get piped in as data, exactly like they would in Relay. So if I go ahead now, of course, we don't need this table of collection data. I'll just take that out. If we go ahead and just give this app code to put it inside the Fluree provider and hop back over to our web app, there we go. So we now have a query that's asking for all events and the attendees. It's piping that data into a very basic React component for events, where each of those events is getting mapped out as an event card. And all that event card is doing is asking for the title of the event, and then is mapping out all the attendees to this text string here. So how to code pretty bad, just Andrew's going to that. How to code good, a few more people are going to that. And the really neat thing that I want to show off now is that if let me move this over a bit, I'm going to pull this out. If I go back to transact some new data, and I now take, and just so that I don't mess this up because we don't have a ton of time, I am going to just take a transaction from here. Let's say that Lillian wants to join the How to Code Pretty Bad event. All I'm going to do is add a transaction where I'm referencing that event, and I'm updating the attendees to include Lillian. Again, just JSON data. I don't want to go too much into the specifics of that syntax, but it's very straightforward. I'm referencing the event, adding Lillian. As I go to transact Lillian in, what's going to happen is we're going to add a new block to the ledger. The ledger will then push the new block state out to every single query peer. We have a query peer running in this app as a web worker. The query that's asking for attendees and events, of course, will return new data. And because new data is getting piped into that component, React knows to just natively repaint the screen. So you see the second I transact that, the second block 4 goes in, this screen has been updated now. We have Lillian and Andrew as attendees. Let me show maybe a more interesting example. What if we had a sort of bad faith, someone's tampering with the database? What if I wasn't thrilled about how my event had been titled How to Code Pretty Bad? And so what I want to do is I want to change that. Maybe I shouldn't be able to change that. That's a question we want to start thinking about is what happens when someone does something to the data that they shouldn't be allowed to be doing. I'm not going to show off permissioning here, but we could set up some permissions in the ledger level that would just restrict that from happening. It would refuse to add this block. What we have regardless, even if we don't set up those permissions, is full traceability of how this happened. So let's say I go in and update this. We'll see now that immediately that front end showed the new title. That was immediately updated. But if we're thinking about databases, the database now, if we ask it for if we go back to that GraphQL query, and we just ask for the event titles, in terms of databases, if we're not thinking about time, if we're not thinking about databases powered by ledgers, we would have no idea, right? If we didn't have logs or some sort of security setup around our app, we would have no idea that this used to have a different title. Databases just know a moment in time in terms of data. We can even think of a worse example. What if someone comes in and they delete both events? First of all, in the React code, in a sort of cool way, we're going to see those disappear immediately. But from a database perspective, now we're looking at the current version of data has no understanding of those events. They're just gone. Obviously, you want to prevent current software and infrastructure sets up firewalls, sets up security, has logs for this sort of stuff. But in general, databases have no sense of what the data used to look like or what should be prevented from happening. One thing that's just really neat about running a database on a ledger-powered data platform is that, of course, the ledger does exist in time. And at any given moment, we should be able to spin up not just a database of the most current version of that ledger state. We should be able to go to any moment in the ledger history and spin up that database. So if I come down here and add in this time travel component, we go back. Oh, I added to the wrong spot. I'm sorry. It's actually in our code that we need to add it, in our React code. So if I just add this time travel component, we're going to see over here just this sort of widget up here. This is not a styling demo, just for the record. But what we have now is we're on block 6, we're at the most recent block state, and we can essentially, what we're going to do as I scale this back, is we're going to be issuing the same queries, but we're going to be issuing them for a moment in time. So we're going to be asking the ledger to spin up a brand new database just from that moment in time. And as we do that, we see actually that we have data that is time historical. We have full traceability going backwards into time to look at this data. And even cooler, our UI can build features that does that just natively. We don't have to add a bunch of really complicated data fields into the way that our database is architected. This is just a native power of having a database spun up anywhere in the ledger we want to go. And in fact, a neat example of this, first let me just show off, we started with no events, we added 2 events, we added Lily into an event, we removed the title, we changed the title of the first event, and then we deleted all those events. We now have sort of full historical possibility, not only with how we're querying the data, but with how we're building out our front end. But the other piece I want to show there is that you shouldn't necessarily have to care about the block data. Of course, we can query this data in time too. More realistically, we would want to see, what did I put it in the wrong place again, I'm sorry. More realistically, we would want to say, hey, I swear that at 8 p.m. or whatever, this data showed a different data state. Like if you're thinking of a data analytics dashboard. So we can do the exact same thing, right? We can do that exact same query, but we're essentially asking to build a database at any moment in time that the ledger existed. And so we can scale fully back and forward just along an axis of time, not just a block axis. So to start to really wrap up this, I just want to go back to just 2 things. One, GraphQL has done really cool things for front-end technology. It's pushed the way front-end apps are built towards a data-centric rather than app-centric approach. And as is clear to anyone who's worked with that doesn't mean we're limiting application features. It means that we're just thinking more about the future of the web, which is going to be more of a data-centric platform. Machines can talk to machines. There's more data transparency. There's more flexibility in what one set of data can power. The next step, of course, is to really be giving data the opportunity to govern itself, to permission itself, to have rules that written into it that write our sort of access, so there's no risk of, there's no risk at the API layer, or the graph layer, or the application layer of having the rules you set up there being bypassed. And as we start to move towards that, it seems obvious that blockchain's going to have has a lot to offer, and we've seen even in front of us right now very easily how quickly we can power an app on those features that a blockchain-powered or data-powered platform could do. It can think about data in time, and it can immediately give our front end the ability to have sort of in-memory speeds of access to that data as it's thinking of data in time as well. So I hope this was neat. I hope it was valuable. I hope you have questions when we actually have this live event. And I do encourage you, if you're interested in anything you saw here today, to look at Fluree's website. It's flur.ee. All of the things that I did today are available. They're free. There's guides to do them. So you could build the exact same app or a much neater one, in no time at all. So thanks for your time. I really appreciate it.